Okay, so I'll explain the point of intersection between L and pi. Okay, so if I have a plane and this is pi representing the plane dot 3 minus 1 2 equals to 2. Okay, then there is a line that passes through it. This line has r equals to 10 4 2 plus lambda 9 minus 1 0. Okay, so we want to find, in part 2 we want to find the vector equation of the line which is a reflection of line L about plane pi. So this is the reflected line. I call it line. There r equals to, we need to find the position vector and the direction vector. Okay, so for one of this position vector, I can choose it to be any point on this line, but the most convenient point to find would be the point of intersection between the line and the plane. Correct. So what we do to find that point, we let that point, I call it N. Okay, and let ON be R. Since it falls on this line, I let it be R equals to let ON be the line equation. I can express ON as the line equation because it is a point on that line, right? So let ON be 10 4 2 plus lambda 1 9 minus 1 0 for some lambda 1 is an element of real. Okay, so we find, well, basically I let this be this because ON is a point on this line, right? So at the same time, this I will substitute this entire ON into this to find the point of intersection between this line and the plane. Okay, so 10 4 2 plus lambda 1 9 minus 1 0 dot product of with 3 minus 1 2 would be equals to 2. Then this would give me 30 minus 4, which is 26. 26 plus 4 would be 30. So it will just be 30 plus lambda 1, 9 times 3 27, 27 plus 1 28, so 28 lambda 1 equals to 2. So minus 28, so lambda 1 equals to minus 1. So if I substitute this back into here, I get the position vector ON, which is equals to 10 4 2 minus minus 1. I substituting this into here, right? Minus 1 times 9 minus 1 0, and that will give me equals to 10 minus 9 is 1, 4 plus 1 is 5, and 2 minus 0 would be 2. So I get ON equals to 152. So I'll just label this point as 152. Then since this point 152 also lies on the reflected line, so I can use it as the position vector. So the task remains to find another point on this line. Any point would do. So what I can do is I would use any point on this line, right? I call it like 10 4 2 because this position vector is on this line, so I know that 10 4 2 is a point on this original line. Or I could use any value of lambda to get another point on this line. It doesn't matter, and it doesn't matter if this point is here or it's here. So it could be a point here, and it's still useful, and I still can get the reflected corresponding reflected point. Or I could use this point and get the corresponding reflected point. I call this point B for convenience sake. Okay, then the reflected point of this, I'll call it B prime, and this will form a right angle. The line joining them will form a right angle, will make a right angle with the plane. This is because if the plane is the mirror, imagine your reflection is always like, if you put your hand to the mirror and to hold the hand of your image, you always form a line that is perpendicular to the plane. So that's how you should look at it. And let's say, okay, so let's call this point the foot of perpendicular of B to the plane. We call it F. So we try to find what is OF first before using the fact that this and this has a ratio of 1:1, the midpoint theorem, to find my B prime. Right, I repeat again. So OF is the foot of perpendicular of B onto the plane, and since the reflected image must be equidistant to the mirror from the F must be equidistant between B and B prime. Okay, so because B, let's say if you stand in front of the mirror, the distance between you and the mirror and your image in the mirror is equal, right? So that's why the ratio of the distance is BF and to FB prime is 1:1. So being 1:1, so okay, I can say that OF equals to OB plus OB prime divided by 2. Alright, OB, we already know that OB is 10, 4, and 2. What we want to find is actually OB prime. And what we need to find is OF, because if we are able to find OF, then we are able to find our OB prime. With our OB prime, then we take B prime minus OB prime minus ON, and I get my MB prime, which will be the direction vector that we are looking for. So let's see what happens next. So let's say OF, to find OF, I will use the line BF and what is the line equation of BF? Okay, you look at this, that R equals to, since for BF position vector, I can use the position vector B, OB, plus mu, because this line equation has a direction vector which is the normal to the plane, which is perpendicular to the plane, in other words. So we can use the normal of the plane as the direction vector of this line. So I will make it like 3 minus 1, 2 is the direction vector of the line BF, and then 4, 2 will be the position vector of OB. Okay, so with line BF, I will intersect this line BF with the plane to find the point OF. So let's see. Okay, so 10, 4, 2 plus mu 3 minus 1, 2 dot product 3 minus 1, 2 equals to 2. Okay, I'm using this plane's equation here. This is my R, this part is my R dot N, which is the normal to the plane, 3 minus 1, 2, as we see here, and the 2 is the 2 on the right hand side. Basically, I'm doing a simultaneous equation of the lines equation with the plane equation to find the point of intersection, which is what OF is. And if you ask me why the line equation is this, is because the line contains the point 10, 4, 2, right? So we use 10, 4, 2 as the position vector, and because this line is perpendicular to the plane, then we use the plane's normal as the direction vector of that line. So then, knowing that line's equation, we substitute into the plane's equation, and we are trying to find the position vector of OF here. So here, that means if I solve this for my mu first to then find OF, so this is 30 minus 4, okay, 10 times 3 30, 4 times minus 1 minus 4 and plus 4. So that is the first part. Then plus 3 times 3 is 9, minus 1 times minus 1 is plus 1, then 2 times 2 is plus 4. That is my mu, okay, then equals to 2. So this is okay, so 14 mu equals to 2 minus 30, which is minus 28. So that means mu equals to minus 2. Knowing that my mu equals to minus 2, if I substitute into the equation over here, right, I will get my position vector OF. So OF equals to 10, 4, 2 plus minus 2 times 3 minus 1, 2. I'm just substituting inside this equation. The mu that I found, I substitute inside this equation. That's what I get, and that is my position vector OF. So this is related. Why I do this is because I intersecting the line equation with the plane's equation, not our original line, but this line that I'm referring to, this line that joins P to B prime. Yeah, this is where it intersects the plane is where the full perpendicular is. Then 10 minus 6 is 4, 4 plus 2 is 6, then 2 minus 4 is minus 2, right? So this is my OF, right? Okay, knowing that is my OF, I will just substitute inside here, and I will get my OB prime. So what is our OF? My OF is 4, 6 minus 2. So I come back and substitute inside here, 4, 6 and minus 2. Is that OF? Yep, 4, 6 and minus 2. Okay, good. So then to get my OB prime, from here I can tell that my OB prime is equals to 2 times this. So I make some change. So 2, I multiply to the other side, I get this 2 times 4, 6 minus 2. And that will give me 8, 12 and minus 4. So this will become 8, 12 and minus 4 after multiplying the 2. Alright. Okay. Then the next thing is I would minus, so right. So I'll get my OB prime very soon. So I erase some of this working to make space for it. So this will be OB prime will now be equals to 8, 12 minus 4 minus 10, 4, 2. I'm taking this and this and bringing the 10, 4, 2 over to this side and subtracting 10, 4, 2 on both sides of the equation to get my minus 2, 8 minus 6. Okay, so knowing that my OB prime is minus 2, 8 minus 6, I since this is OB prime, I put minus 2, 8 minus 6. Okay, so then remains the direction vector. Now the direction vector of the reflected line. To get the direction vector of the reflected line, I take MB prime. So MB prime is I can take minus 2 minus 1 is minus 3, 8 minus 5 is 3, and minus 6 minus 2 is minus 8. So that gives me my reflected lines equation. So this is our final answer. Okay, thank you.